I grew up, I'm a first-generation Cuban-American. Came to the United States finally in 1959. Before that, we'd go back and forth between Cuba and Miami. And then, so finally, in '59, when I was 7, we just stayed in Miami the rest of the time. About a little while after that, my dad started taking flying lessons, and he had a terrible fear of heights. He had gone up to the top of the Empire State Building, oddly enough, and got to the edge and got that panic that a lot of people get. And so he started flying. He says, "I'm going to beat this thing." And unfortunately, he was a surgeon, so his flying skills never got that good. But one of the great things that happened was I ended up borrowing half of one of his flight lessons to go up in a little J3 Cub. And as they say, the rest is history. I said, "This is just too much fun." I had I think it was an F-15 assignment that they gave me, but at the same time, this is 1980, and two of our former test pilots that were working with me at Eglin had been picked up in '78 to go to the astronaut program. So they came back and they were looking for more astronauts because we had not flown the shuttle yet. And I said, "Well, guys, I'm not exactly, I'm still kind of a young kid. I'm 27. I don't have the qualifications to be an astronaut, but, is there anything there for a young puppy like me?" And they said, "Oh, absolutely. We have research pilots that fly all the research aircraft." And I said, "Really?" So I signed up for that and got the job. Well, the only job I really had, along with other jobs, the main job was research pilot. And the research pilot flies the research aircraft. And what we do at NASA is most of our airplanes, we had 9 different types of airplanes over my career that we flew out of the Johnson Space Center in support of spaceflight missions. And what we did there is we would take an airplane and we'd modify it. And we say, "Yeah, that's very cute. The aircraft manufacturer wanted this to be the aircraft envelope, but we're engineers. We can do other stuff with it." For example, everybody loves the Vomit Comet, the microgravity airplane. I was an instructor on both the KC-135 version, which is a Boeing 707-ish model, and also the DC-9, which is a twin-engine airplane. So I was all of the pilots that flew that, I instructed them. So I had a great time with that, fantastic time with that. Oh, let's see, I flew the 747 shuttle carrier. That was amazing. I enjoyed that. The 747 is a joy, absolute joy to fly. Super design. It's a puppy dog in flight. It's about as gentlemanly an airplane as you can imagine. Just very docile. And then you put an orbiter on the back. And what a pig. So the whole time you're flying, it's shaking. It's pretty noticeable shake. So you're shaking the whole time. And you can't go very fast. You can't go very high. We couldn't take it above the freezing level. So you're down about 15,000 feet is about as high as you could go. The orbiter on the 747 is up at an angle because it lifts its own weight. Well, it does nothing for the drag. You still have that drag. So you can feel the vortices it's putting out are running over the tail. So that's what you're feeling, is it's shaking the whole vehicle. And also it's up pretty high, so if you roll over, it kind of wants to keep going. And off you go. And also you're burning gas like crazy. I was happy when I got the fuel flows below 10,000 pounds per hour per engine. Yeah, so a 747 can go from, used to go from New York to Japan nonstop. We couldn't go from LA to El Paso sometimes. So it was one of those that it was very, very difficult. Plus, you've got a national asset sitting on top of your airplane. So we really had to take care of it. We would have another airplane in front of us, a Pathfinder, looking for weather. And there was occasions he goes, "Sucks, don't go." And we would turn around, we'd land. because we're taking care of the vehicle. And actually, there is some dead air. Any swept-wing aircraft, most aircraft, you have a directional control issue. It'll sit there and hunt, and it's kind of annoying, but not a big deal. And because of that, most vehicles of that size have a yaw damper, and the rudder will kick, and it senses when the nose starts moving and it stops it. Well, the rudder is blanked by the orbiter, so what would happen is you'd be sitting there in autopilot. We'd always do that so we can monitor the systems very carefully, all eyeballs. And you'd be flying along, and all of a sudden you'd feel like this, and about 2 degrees is all, and you could feel pulses. And what would happen is, and this is me thinking, is the yaw damper's back there going, but it's in dead air until it gets into a side slip, and then it would kick and go, hey, so kicking on the, and you would do that all the way across the country. So it's like, so, but it was, and it was very subtle, but you could feel it. And of course, the whole time you're shaking. So that was kind of fun. We were very worried about that because, of course, you have tremendous drag, and they weren't too worried about the vibrations that you're getting off the turbulence. It turns out we probably should have, because we had secondary structures did crack on the 747 because of that, and that's why we probably discontinued the well, not probably, that's why we discontinued that the tail cone off part of it. But what we're really worried about is if you do the math, the drag is tremendously different with tail cone off. And when you release, we were worried about it coming back and hitting the tail. And because of that, we had some very strong escape maneuvers that we used, that the 747 pushes away and the orbiter pulls. Well, you can't pull too much, because if you pull too much, you get too much drag. And then you will run into the back. So we had this all calibrated out. And the math says you miss it by 1.5 feet. Well, 1.5 feet is in the noise. That means you hit. So we did all this different kind of machinations, and if you look, it's not 1.5 feet, but it gets close. But we were able to ameliorate a lot of the risk and get rid of some of the issues, and we did it once. We did it successfully. So yay. No. The safety of the vehicle is paramount. So, and plus, there's no way to get rid of it. It wasn't carded. There's no explosive bolts. It's stuck for life. And that's why we picked the 7.4 more than anything. Is reliability of the 747 was unbelievable. It's dispatchable, and it just works like crazy. And I never had a problem with the airplane where I couldn't. Redundancy was off the charts. I never lost any flight control surface that I couldn't recover somehow. You could run it by hydraulics, pneumatics, power of thought. The thing was amazing. Joe Henry Engel had come to the management at the time and said he wanted to build something that Joe Henry, you have to understand Joe Henry, he's just a character and a half. Probably the best set of hands I've ever seen in my life as a test pilot. That guy could tell if something was off just by sense of smell. And I'm flying, things, and I'm going, I don't feel anything. He goes, no, Charlie, look, watch the roll rate left and right. Okay, see how they're different? Now there's a problem here. Okay, we get it to the ground, and sure enough, there's a problem. It's like, holy cow. So, Joe Henry, you have to understand, had a great set of hands on him. So, and really, really sharp with respect to flight tests. And he says, we're going to be up there for a month and not fly an approach. This is for extended duration orbiter. And we have to have something that can, tell us, as he says, you poke the horse and see what it does. And I said, well, Joe Henry, can we be a little more specific? I don't know want to put that into a request for proposal. He goes, I don't know, Charlie, what do you think? I said, well, why don't we build a simulator and do it? So he says, that'll work. And so do a landing simulator. And so we started down that path, and at the time, the technology was not there. Absolutely not there. Neither the screen resolution was there, and the computer power was definitely not there. And then so I went to Boeing, or I should say we went to Boeing, asked them. They said, oh, it'd be $5 million, 5 years. Okay, thank you. Went to Lockheed Martin, $5 million, 5 years. Everybody was that, and I said, this is unsatisfactory. And these guys had beautiful proposals, but that doesn't fit in what we needed. So I started. Don't know how. I think I do. One of the Japanese astronauts, Koichi Wakata, and we're drinking after work sometime, and he brings up the fact that he'd just seen the most beautiful computer from Panasonic. I mean, this thing's got a huge screen, Charlie, and oh my gosh, the power on it is awesome. It's a Unix machine, and my eyes are going big, and I go, Koichi-san, can we get a hold of one? I'd like to, oh, I've got one over here. So we go look at it, I do a benchmark on it, I go, holy cow, this thing will work. And we said, well, why don't we do it? Well, and then talked to Joe Henry, and he goes, well, where are we going to get a rotational hand controller, a stick? And how are we going to mount it? And I go, I don't know, the details. And we got a team together, and long story short, we flew that in about 6 months, and buying 4 computers and 4 rotational hand controllers for less than $500,000 total. Title, tax, license. One of the best success stories. Let somebody loose at NASA with a job, and we'll do it. We'll knock it out of the park, and we did. And Pilot flew in one form or another on every mission after that. And the pilots had nothing but praise for it. And the benefit of it was not what we expected. The hand-eye coordination issue. It was an approach in the shuttle is a dance. It's a give and take of information back and forth between the two pilots. Very, very tight and very choreographed. And what they found was that they didn't have their timing down because it had been a couple of weeks, and they were stepping all over each other. It's like, I got it wrong, and I didn't know what my airspeed was, didn't know what my sync rate was. And he goes, yeah, we got to fix that. So they do the approach on Pilot, and they found out within two or three approaches, they had it down pat. They did it the day before landing, and they said, well, I want that. And it turns out the numbers, we would take every single parameter you can imagine on landing, and I actually had a score and that we developed. That unfortunately it was JNUM, because J is a cost function. They started calling it the Justiz number. Great, thanks. We looked at this cost function, and it was kind of all over the place until you got your training down pat, and then it always hit a number, it hit a groove, and you stayed within a point or two of that number out of 100. So very, very repeatable if you're trained up. And we looked at orbiter landings up to Pilot, and they were all over the place. I mean, people were just scattergunning. And then after Pilot, everything just locked right in, and they were within a point again of these parameters, just because they got their cadence down correctly. So that was a big surprise to me. I did not expect that result. Excellent career, excellent fun airplanes to fly, great cadre of people. Couldn't have asked for anything better. It was just fun, and we had our problems. We solved them. It was a fantastic opportunity, and anybody gets a chance to work for NASA, I would take it immediately. I don't care. Any seat, any mission.